This video is about function of several variables. The purpose of this video is not to give you a detailed lecture, but an introduction such that when you read a book, it's easier for you to understand. Okay, the function we are talking about here is depend on more than one variable. Say fxy. Okay. So when we talk about functions depend on two variables, it's nice to recall the function depends on one variable, which we're familiar with. Y equal to fx. The graph for the function depends on one variable, y equal to fx. The graph is a curve. It's a curve on the xy plane. Because when you give x, you can find y. Okay, give another x, you find another y. Connect those points, you got a curve. Okay. For example, y equal to x squared, which give you a parabola. Okay. Okay. So how about a function depends on two variables? What is the graph associated with it? That's the first thing we need to figure out. Okay, think about this. In the xy, in the space x, y, and z, for the given xy, give a point in the xy plane, you plug in there, you find a point in space. This point is xy and fxy. Give another point in the xy plane, you can find another point in the space. So think about this is your domain. For given every point here, you can find point in the space. So you connect those, you would get a surface in the space. Okay. So first thing I want you to remember is the function depends on two variables. It's a graph, it's a surface, which corresponding to the function depends on one variable, which its graph is a curve. Okay. So if you understand this, the sense for the later on will be easier and make sense to you. Okay, when we talk about functions, the first things we're going to deal with is the domains and the ranges, just like the function depends on single variable. Okay, what is the domain? Domain of a function depends on two variables. Are those x, y, which you are interested at the same time make this function well defined. For example, z equal to square root 1 minus x squared minus y squared. Okay, this is the example of function depends on two variables. So what is this sense? Remember, function depends on two variables. Its a graph, is a surface. So first of all, it's a surface, but for this specific function, what kind of surface is that? In fact, this gives you top half of the sphere as a origin, as a center, as 1 as a radius. Okay, so let's use this function as an example and see what it is. It's a domain. Okay, the domain, this function has been defined this way, and we know the square roots. Square roots is involved in the definition of this function. And we know the sense inside square roots must be non-negative. So the value in the square root for this function is 1 minus x squared minus y squared. So we want this total quantity non-negative. Otherwise square root function doesn't make sense, not defined. So the domain of this function depends on two variables. Let me use domain. For this function is all the points x, y on the xy plane, and such that 1 minus x squared minus y squared bigger than 0. Okay. So this set is a region in the xy plane. Now let's sketch this. Let's sketch the domain. Okay. So what kind of region this one looks like? And let me rewrite this sentence: x squared 1 minus x squared minus y squared. Just take an equal sign first. Okay. So what is this? All the xy satisfy this equation. Let me rearrange this. Give you x squared plus y squared equal to 1. Therefore, this give you x squared plus y squared give you 1, give you a circle. Okay. And you want to 1 minus x squared minus y squared bigger or equal to 0, equivalent to say x squared plus y squared less or equal to 1. Okay. So that means as long as your x, y, you pick a point in this shaded region, they will have, pick any point x, y here, they will satisfy x squared plus y squared less than 1. In other words, 1 minus x squared minus y squared will be bigger or equal to 0. So this will guarantee the number in the square roots. If you chose your xy in this shaded region, they will guarantee 1 minus x squared minus y squared will be non-negative. So that square roots make sense. Okay. So this circle, unit circle, everything inside give you the domain. Okay. What's the range of this function? Range of a given function is possible z value. When you chose your xy in your domain, what is the possible fxy value? Obviously, since my fxy here is the square root 1 minus x squared minus y squared, therefore we know the square roots cannot be negative numbers, so this is always non-negative. Okay. So your range for this case is between 0 and infinity. Wait, not infinity. Between 0 and what? 0 and 1. So that's your range. Possible fxy value. Okay. Right? When you chose the xy both 0, you got a 1. Okay. Okay. So now let me give you another example. We want to sketch the domain for the function fxy equal to square root x plus y. Okay. First of all, this function gives you surface. Okay. Now its domain is a possible x and y value such that this function well defined. Again, this function with square roots involved. Okay. So therefore the sense inside of square roots must be non-negative. Therefore your domain must be those possible x and y value such that x plus y is bigger or equal to 0. Okay. So how do we sketch the domain? All those possible x and y value there. This x and y. Okay. So your domain you can write is a set. All the xy point xy in the xy plane such that x plus y is bigger or equal to 0. Okay, now let's sketch this. Let's see what this set looks like. So I would suggest you always do this. Make the equal sign. What is this? X plus y equal to 0. Or you can say y equal to minus x. This will give you a line like this. This is y equal to minus x. Okay. Now, so we know that every point on this line will be in your domain. But how about x plus y is bigger or equal to 0? Okay. Now, we have two sides. One is above this line, one is below. Okay. Now, you just need to check one point. For example, we pick a point 1 and 1. You plug in there. X is 1, y is 1. Obviously, this is equal to 2 is bigger or equal to 0. So this will just tell you this side of it. Okay, this shaded region will be your domain. In other words, you pick any point in this shaded region that will make your function well defined. Okay. Okay, by the way, how about a range for this one? For pick xy in this domain, what is the possible fxy value? What do you think? Range obviously could be 0, right? You let xy both 0, you got a 0. How about that? You can make xy arbitrarily big, so infinity. Okay. Okay, now let me give another example. Try to understand function depending on two variables. Okay. For example, my fxy equal to 3. We want to sketch the graph. Okay, this function is simple. Just like you said, I don't see xy in this expression. What this means? This means for giving x and y, my fxy equal to 3. Okay. First of all, I want to understand what's the graph of that. Remember, function depends on two variables. In general, its graph is what? Surface, surface, surface. Okay. So the question is what? What kind of surface is this? Okay, now let's take a look. X, y, and z. For giving x, y here, you plug in, you got what? Z equal to 3. Give another x, y, plug in z equal to 3. So now you probably get some idea. I suggest you always put a z there. Okay. So fxy equal to 3 means this function you also can write z equal to 3. So what is z equal to 3? Obviously is what? Is a plane. Okay. This plane parallel with xy plane, and the distance to xy plane is what? 3 units. Obviously, every point on this plane, they have their xy can be anything, but z must always 3. Okay. Another concept, important concept in this section is level curve. Okay. Okay. If you read a book, level curve, they said, is a curve determined by this equation. Okay. Now, let me tell you what is this curve. Okay. I want you to understand this curve is like this. There's two things. One is z equal to fxy. One is k equal to fxy. The first one is a surface. The second one is a curve. Okay. Why the second one give you curve, and what kind of curve is that? Now, this really means this. You got one surface. And the second one, okay, z equal to k. Combine those, you got what? You got f xy equal to k, right? So what that means? That means, okay, z equal to fxy is the surface, and z equal to k is another surface. Intersection of those two surfaces give you a curve. That's which we call the level curve. Let me give you an example. We'll use this one as an example again. Surface, half of the sphere, okay? Okay, I told you before. First of all, it's a surface, and this is a special surface which give you top half of the curve. Okay. Why they give you top half of the curve? I think many of you probably know this. X squared plus y squared plus z squared equal to 1. Give you the surface. Okay. Give you the sphere. Now, if you solve for the z, so they give you positive and negative square roots of 1 minus x squared minus y squared. If you pick the positive sign, you got top half of the sphere. If you pick the negative sign, you got the bottom half of the sphere. Okay. So, we have a surface. Then you let z equal to 0. Okay. What is this? Z equal to 0. Ask yourself. What is z equal to 0? What is the graph of that? Remember, surface. So, what is this surface? XY plane, right? Z equal to 0 give you XY plane. Okay. So, you combine z equal to 0 and with this one. What this means? That means you use z equal to 0, which is a plane, to intersect your top half of the sphere. What do we get? Obviously, you got this circle, right? You got this circle, which you got this circle as a origin, as a region, as a center, as a radius 1. Okay. So the level curve is use z equal to k to cut your surface. Intersection give you level curve. And given, say, how about, this is the case, k equal to 0, okay? How about the k equal to 1/2? So, k equal to 1/2, then you got another level curve like this. Right? fxy equal to k give you a level curve, okay? Which means use z equal to k to intersect your surface, okay? So this one give you another curve. What curve is that? Okay, here's 1/2. So you use z equal to 1/2, which is another plane, to cut your surface. You got another circle. Okay. You got another circle. This circle with radius is smaller than 1. So Also, you can say, okay, I let k equal to 2. Then you got what? Level curve is your 1 minus x squared minus y squared equal to 2. Now let's see what kind of curve is that. Okay. So you square both sides. You got 1 minus x squared minus y squared equal to 4. This means x squared plus y squared equal to minus 3. Okay. So what kind of curve is that? You can tell this no matter how you pick x and y, then never give you negative 3. So what that means? Remember our surface is top half of the sphere. Okay. Now if you use z equal to 2, if you use z equal to 2 to cut your surface, z equal to 2 is a plane here. You have no intersection, so you don't get any curve. Okay. So if you read a book, they will tell you, say, the k must be in the range of your function. Remember the range for this function is what? 0 and 1, right? 2 is out of there, so you don't get the level curve. Okay, the purpose of level curve is, for example, look at the map. We know the surface of the earth, you got a mountain and some place higher. If you want to represent those things on the plane, so that's why we have those level curve. For example, on this curve the altitude is 100, on this curve your altitude is 50, and so on and so forth. Okay, that's what level curve. So if you understand z equal to fxy, the function depends on two variables, surface. Then you would understand what is the level curve means, which means you use z equal to k, which is the plane, which is parallel with the xy plane. To cut your surface, you got a curve. Okay, now go home, read a book.